Hello there, GED math students or any math students. In this video, I am going to show you how to do long division without a calculator. There are 4 questions in this video. The first 3 are straight up long division, and then the last one I will show you how to use long division to convert a fraction into a decimal. Let's jump into this one. Step 1. You want to rewrite this here in this form. So it's going to be written like this. 5176. So you need to realize that you read this as 5,176 divided by 8. You read this as 5,176 divided by 8. This one you read kind of backwards, but the thing you're dividing by 8 goes on the outside here. This is called the divisor. So you need to be clear that these two things mean the same thing. So I'm going to write it in this form. There's many ways to do this. I'm going to show you a method here that's really going to help you if you struggle with your multiplication facts. So we're dividing by 8 here, right? So what I'm going to do is make a list of 9 numbers. I'm going to start with my divisor, 8. I'm going to start with 8. For example, if this were 10, I'd start with 10. If this were 32, I'd start with 32. It's 8. So since it's 8, I'll start with 8 and I'll count by 8. So I'm just going to jump up by 8 each time. So this would be 16, 24, just adding 8 each time. 8 plus 8 is 16. 16 plus 8 is 24. 24 plus 8 is 32. And you'll just continue this process until you get to 9 numbers on your list. So it would be 56, 64, 72. Now, this 8 is the first number in the list. So I'm just going to write a 1 here. 1. Second number, 2, 3, 4, 5, 6, seventh number on the list, 8, 9. Now what you've really done is generated a times table. If you think about it, 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24, and so on. 8 times 4 is 32. 8 times 5 is 40. And you can continue that process to 9. I am not going to show this 8 times, but it's there. Just remember it's there. I don't want to show it because it'll make this process cleaner and easier to read, so I'll just get rid of it, even though it's really there. So watch how I do this. I'm going to go over here and I'm going to look at 8. And the first thing I am going to do is say to myself, how many times does 8 divide into this 5, into this first digit? Or how many 8s can I pull out of 5? Or how many 8s make up 5? Well, 8 is bigger than 5. So when that happens, you just put a 0 right above the 5. The reason I did that is because 8 is bigger than 5. Then what I do when that happens is I just combine the first 2 digits right here, the 5 and the 1. I just combine these two and say 51. And now I'm good to go because 8 is not bigger than 51. So what I say to myself is, how many 8s make up 51? Well, what I do is I go over here to my list, to my white numbers here, and I see if 51 is on this list. Is there a 51 on this list? No, there isn't. That just indicates that 8 does not divide into 51 exactly. So when that happens, what I'm going to do is say to myself, actually I didn't mean to erase that right there. Let me leave that in there because we're dealing with the 51. When I say to myself, okay, what number on this list with these white numbers is closest to 51? Does not go over 51. Let's see. That would be 48. 48 is the closest number to 51 without going over it. The next number, 56, goes over 51. So I'm going to use the 6th number in the list, the 48. So I say to myself, how many 8s make up 51? Well, about 6 of them. So since I picked this number, it's the 6th number on the list, I'm going to put the 6 right above the 1 here, like so. And then I say to myself, Or I multiply 8 times 6. Well, what's 8 times 6? Well, 8 times 6, remember there's an 8 times right here. 8 times 6 is 48. I just continue this process. So 8 times 6, 48. I put a 48 right here, right below the 51, and I subtract. So that's what I'm going to do next. Let's subtract 51 minus 48. And what do we get? What's 51 minus 48? Well, that's 3. And then the next step is just to bring down this number here, the 7. So bring down the 7, and then I continue this same process. I say to myself, how many 8s make up 37? Is there a 37 on this list? No. So since it's not exactly on the list, I say what number here is closest to 37 without going over? That's 32. That's the 4th number on the list. So I put a 4 right above the 7. And I say 8 times 4 is 32 from right here. I write that 32. 8 times 4 is 32. I write that right below the 37. I subtract. What's 37 minus 32? That's 5. And then I bring down my final digit. This is my final digit, so I might be done. I bring down the 6. Then I say to myself, okay, is 56 on the list? Boom, it's right here. That just indicates that 8 divides into 56 exactly. In other words, there's 7 8s in 56. So 56 is on the list. It's right here. It's the 7th number on the list, so I put that 7 right above the 6. 8 times 7 is 56. I write this 56 right below this 56. I subtract, and 56 minus 56 is 0. So there's no remainder. It comes out perfectly, and I'm done because I've used every digit here. I've brought down every digit. So my answer is 647. There we go. Now you don't need to show this 0. Just show the 6, the 4, and the 7. Let's go to another one. This one's a little more difficult because we're dividing by a 2-digit number, but the process is the same. So I'll rewrite this. I'll put this on the outside. The 23 will be on the outside. And then I'll put this number here on the inside, 37927. Here we go. We start with 23 because that's my divisor. So I start with this number, and then I generate 9 numbers, and now I'm going to count by 23. And you can see why this is a little bit more difficult, but we could do this. So 23, what's 23 plus 23? Hopefully you can see that's 46. What's 46 plus 23? Well, let's see. Here's how I kind of do this in my head. 46 plus 23. I just do it this way. I go 46 plus 20, and then I add 3 because 20 plus 3 is the same as 23. So in my head, I'm going 46 plus 20 is 56, 66 plus 3 more is 69. That's how I do that process in my head. So 46 plus 23, add 20, then add 3. So 46, 56, 66, then add 3 more is 69. 69 plus 23, 69, 79, 89, and then add 3 more, that's 92. All right, let's do 92 plus 23. Go 92 plus 20, and then add 3 more. So 92, 102, 112, then add 3 more. That would be 115, and just continue that process. 115, let's see, that would be 125, 135, 138, then 138, 148, 158, 161, and then 161, 171, 181, 184, and then let's see, 184, 194, 204, 207. So I'm trying to model how to add by 23. That's what I'm trying to do. There should be 9 numbers here. 1, first number, 2, 3, 4, 5, 6, 7, 8, 9. And again, this really means 23 times 1 is 23. 23 times 2 is 46. 23 times 3 is 69, and so on. Now we're going to do the same thing we did previously. I look at this 23 right here. And I say to myself, how many times does 23 go into 3? Or how many 23s make up 3? Well, 23 is bigger than 3, so I put a 0 right above the 3. Now I'm going to combine the first two digits, the 3 and the 7. How many times does 23, or how many 23s make up 37? Well, maybe you can see this is going to be a 1 here, but you can use your list, right? I say to myself, okay, 37. Is 37 on this list? No, it's not. So then I say to myself, what's the closest number on this list to 37 without going over it? That would be 23 right here, because 46 goes over 37. So 23 is the first number on the list. So I put this 1 right above the 7 here. And 23 times 1, actually before I do that, let me erase this. Now I multiply this 23 by this 1, and 23 times 1 is 23, right here. We subtract. What's 37 minus 23? Well, let's see. 7 minus 3 is 4. 3 minus 2 is 1. Now I bring down my 9. Now I have 149. Well, is 149 on the list? No. So what's the closest number to 149 without going over? Be this one, 138. And that is the 6th number on the list. So I put this 6 right above the 9. Then I say 23 times 6 is this number right here. It's 138. I put that 138 right below the 149. I subtract. 9 minus 8 is 1. 4 minus 3 is 1. 1 minus 1 is 0. You do not need to show this 0. Now I need to bring down the next number. I bring down the 2 right here. Is 112 on this list right here? No. So what's the closest number to 112 without going over it? Right here, it's the 92. The 92 is the 4th number on the list, so I put the 4 right above the 2. And I say to myself, what's 23 times 4? Well, it's this number right here, 92. So I bring this 92 and I put it right below the 112 and I subtract. Well, what's 112 minus 92? Well, let's see. 2 minus 2 is 0. Right? And then I can borrow here, make that a 0, turn this into an 11. 11 minus 9 is 2. It's 20. Or you could have just done that in your head if you wanted to. So in short, clean this up, 112 minus 92 is 20. And what do you think I do next? I bring down my last digit, and hopefully I'll be done after this. Bring down my 7, and I say to myself, okay, 207 is 207 on this list. Yay, it is. It's right here, right? That just tells me that 23, there's exactly 9 23s in 207. It indicates that 23 divides into 207 exactly because 207 is on the list. 207 is the 9th number on the list, so I put a 9 right above this 7. And 23 times 9 is 207. And there's no remainder. When I subtract at the end and it's 0, and I brought down every digit, I'm done. So my answer here is 1649. Again, you do not need to show this first 0. So in short, 37,927 divided by 23 is 1,649, and you did the whole thing without a calculator. Let's go to the next one. All right, this is divided by 12. Let's do this. It's a similar process. You're going to see this is slightly different. I'm going to need a little more room here. You'll see why in a second. So let's rewrite this as 8, 7, 6, 3, 4. Okay, and on the outside goes the 12. Hopefully you're starting to get the hang of this process. So we'll generate a list of 9 numbers. We'll start with 12, and we'll count by 12. So 12, 24. 24. What I'm doing is I'm going to add 10 to this, then 2. So 24 plus 10 is 34, plus 2 more would be 36, then 48, then 60, then 72, then 72 plus 12 is 84. 84 plus 12 is 84, 94, 96, and then 96 plus 12 is 108. I believe that's 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's do this. Let's take the 12 right here. Right here, this 12. How many times does 12 go into 8? Well, 12 is bigger than 8, so I put a 0 here. And now I just combine the first 2 digits, the 8 and the 7. How many times does 12 go into 87? It's not on the list. The closest number to 87 without going over is 84. And that's the 7th number on the list, so I put the 7 right above this 7. 12 times 7 is 84, and I hope you're starting to get the hang of this. Now let's subtract this out. 87 minus 84 is 3. Bring down your 6. How many 12s make up 36? Let's see, here's 36 on the list. Is this 36 on the list? Yeah, it's right here. So exactly 3 12s make up 36. So this 36 is on the list. It's the 3rd number on the list, so I'll put the 3 right above the 6 here. And 12 times 3 is 36. So I'll write this 36 right below this 36. Let's subtract that out. That's 0. 36 minus 36 is 0. Okay, now let's bring down the next number, which is the 3. How many times? Now I'm not going to show this 0 here now. I'm just going to erase it. What I'm basically asking is how many 12s go into 3? Well, 12 is bigger than 3. So be careful here. When that happens, you need to put a 0 above this 3. Right? Because 12 is bigger than 3. And what you're going to do is bring down the next number now when that happens. And that's a 4. Again, do not forget to put that 0 here above the 3 because 12 is bigger than 3. So I put a 0 kind of as a placeholder here. Bring down the 4. Let me just get rid of this. There we go. And what do you think here? What's the next step in this process? Well, let's see. How many 12s make up 34? How many 12s make up 34? Well, let's see. That's the closest number to 34 is 24 right here. Without going over. That's the 2nd number on the list, so I'll put a 2 right here. This 2 goes right here, right above the 4. What's 12 times 2? 12 times 2 is 24. Write that 24 right below this 34 and subtract, and we get 10. 34 minus 24 is 10. Now, we don't have a remainder of 0 here. So here's what you got to do when this happens. I need to extend this out. Give me one. And that's what makes this problem harder, a little more difficult, I should say. Some teachers will just say you have a remainder of 10. But for the GED math test, it's going to be a little more complicated than that. I'll show you how to add a decimal piece onto this. So I'm not finished because I didn't get a remainder of 0 like we did before. So here's what I'm going to do. There's always a decimal point at the end of the number. I'm going to write it in, and you can add zeros. It doesn't change anything. I'm going to add 3 for this problem. Think about it. Let's say you had $5. There's really a decimal point at the end of any whole number. If I add a 0 to it, you still have $5. If I added, let's say I added 4 zeros to it, these all mean $5. By putting in that decimal right here and tacking zeros on does not change the value of the number. And that's really what I did here. I didn't change anything. So keep that in mind. That's why I can do that. And now I can start bringing down zeros and do the same process. I'm going to bring down this 0 here. Okay, so let's bring that down. Let me get that all in the same color for you. You can see why they call this long division. It takes a long time. But let's keep going here. So how many 12s make up 100? Well, is 100 on the list? Is 100 on this list here? No, 100's not on the list. What's the closest to a number to 100 without going over here? That would be this one, 96. That's the 8th number on the list, so I put an 8 right above this 0. Don't forget to bring up this decimal point. That was my bad. Right away, this decimal point, you got to bring it up right here. So bring it up right here. And then put that 8 there. And let's see, it was the 8th number on the list. So 12 times 8 is 96. Put that 96 right below the 100 and subtract. What's 100 minus 96? That's 4. Bring down your next 0. You just continue this process. Sometimes this goes on forever. It could. Bring down this 0. All right, is 40 on the list here? Let me see. Is this 40 on this list? No. So the closest number to 40 without going over is 36. That's the 3rd number on the list. So I put the 3 right above this 0. 12 times 3 is 36. I'm going to subtract. What's 40 minus 36? That's 4 again. I bring down this 0. Right here. Bring down this 0. And this is 40 again, just like it was here. Let's see. How many 12s make up 40? Well, it's not going to be exact. It's going to be the same thing again. Watch. Again, 40 is not on the list. Just like here, if you notice, this number is the same as this. So the closest number to 40 without going over is, again, 36. That's the 3rd number on the list. I'll put a 3 here above this 0. And again, 12 times 3 is 36. I subtract again, and I would get, I'll write it over here, I'll get 4. I'm running out of room. If you continue this process forever, you'll get 3, 3, 3, 3, 3. This 3 repeats. So basically, after all this, hope you're still with me, this is what we get. This is my answer. It's 7302.8333333. This 3 will, if you continue the process, the 3 will continue to repeat. So watch how I'm going to write my final answer. I'm going to put a bar over this 3. That indicates that the 3 repeats on forever. It just keeps going if you do that process. So I just put the bar over the 3, not the 8. Only the 3 is repeating. The 8 isn't. And this is my final answer. 7,302 or 7,302.83 with the bar over the 3. So that's how you deal with long division when the remainder is not 0 and you need to make it into kind of a decimal like this. And that is the answer. So in other words, 87,634 divided by 12 is 7,302.833333. Let's do the last problem. You might see this. It says write 4 sevenths as a decimal. I'm going to take it out to 2 or 3 places. So you need to remember that this means 4 divided by 7. Let me get the right color here. 4, this is a fraction. This is a division bar right here. This means 4 divided by 7. That's really what that means. So when I rewrite that, I'm going to rewrite it like this. I'll put the 7 on the outside and the 4 on the inside. So you're going to rewrite this like this. So let me do that. I'll put it over here. And one way to look at this is the denominator becomes your divisor, goes on the outside, and the 4, the numerator, goes on the inside. Now, let's do this process. Remember, there's a decimal point here. I'm going to put it here. And this is something you might have to do on the GED math test. How many times does 7 go into 4? Well, 7's bigger than 4, so I put a 0 here. Now what do? Well, just like I showed you before, we can tack on zeros, right? Right? These all mean the same thing. So I'm just going to add zeros after this decimal point. Remember, there's always a decimal point at the end of a whole number if it's not shown. So what I'm going to do first is what I should have done before is bring up this decimal point here, and then I'm just going to add 3 zeros. I'm going to go out to 3 places here. You could go out to as many places as you want. Well, I'll go out to 3 places, and let's start the process. So it's the same thing. I'll put my 7 here, and I'll just count by 7. So 14, 21. If you watch football, you can do this pretty quick. They're like touchdowns, and this is 35, 42, 49, 56, 63. So this is the first number on the list, and you can see this is the same process. Second, third, fourth, fifth, sixth, seventh, eighth, ninth number, right? So 7 times 1 is 7, 7 times 2 is 14, and so on. We're going to go through the same process here. So we first realize that 7 doesn't go into 4 because 7 is bigger than 4, so I put a 0 here. And then I combine these digits right here, the first and second digit here. Pretend this decimal isn't here. Just look at this as 40. In your mind, erase this decimal here. So 40. Is 40 on the list here? No. So what number is closest to 40 without going over it? It's 35. That's the 5th number on the list. So I put the 5 right above this 0. All right, and I should have this color coordinated, so let me make this green as well. Close enough. All right, 7 times 5. I take the 7 times this 5 is 35 right here. Let me erase this right here. And I think to myself, 40. Again, I'm thinking 40, not 4.0. 40 minus 35 is 5. Bring down your 0. All right, how many 7s make up 50? Well, is 50 on the list? No, 50's not on this list here, right? It's not on the list. So what's the closest number to 50 without going over? It is 49. So it's the 7th number on the list. So I'll put a 7 right above this 0. And then I'll say 7 times 7 is 49 from here. I'll put that 49 right below the 50. And I'll subtract. What's 50 minus 49? That's 1. Bring down your next 0. I'm doing this to 3 places. That is, bring down this next 0. Well, let's see. How many 7s make up 10? Well, again, 10's not on the list. Hopefully you can see this is going to be a 1 here, but if you're stuck on that, just use the list. Again, let's see what number on the list is closest to 10 without going over. Well, it's 7. That's the first number on the list, so I'll put a 1 here. 7 times 1 is 7. Subtract, and I get 3. I can go on and on. This number will go on forever. You can continue this process forever, and it won't repeat. I'm just going to go out to 3 decimal places because this process will go on and on and on, and I'm just going to write it out to 3 decimal places and say 4/7 is equal to, 4/7 is about, and I'm putting these squiggly lines because this is an estimate because it really keeps on going. So my answer out to 3 decimal places is 0.571, like so. And that's my answer. Now, if they wanted you to round this to the nearest cent, this is about 57 cents. It's about 50. If this were money, it'd be about 57 cents. That's another way to look at it. So 4/7 is about 57 cents, but I took it out to 3 decimal places. Over here, I just dropped off the 1 and said about 57 cents. So you might have to do something like this on the GED math test. And I hope you found this process useful, and I hope you have a better grasp of how to do long division. And again, with this final answer here, I could continue to bring down zeros here. If I were to do that, if I brought down another 0 here, I could continue this process actually forever. And the reason that is because this is technically an irrational number. The decimal goes on forever, and I believe it doesn't repeat. I should probably check that real quick on my calculator. Let me check that. Yeah, this number goes on forever and doesn't repeat. So if you want to keep going, you can go out to 5 decimal places, 100 decimal places, but that would get kind of tedious. So in short, I hope this video was helpful. And as always, thanks for watching my videos. And good luck when you take the GED math test or any math test you have to take. Have a great day.